So hi coders, today we are going to solve fifth problem in top interview questions of Leetcode. Okay, so here's the question. Given a string S, return the longest palindromic substring. So first of all, what is palindromic? So any substring where the first character is equal to its last character. For example, A, B, C, B, A. So here A, this A is equal to the last A, and the second character of is the string which is b is equals to the second last character, and similarly. So we need to find longest palindromic substring. The substring is basically a part of a string which can start anywhere from any index and end at any index. Okay, let's understand this question through an example. So here's a string BABAD. So we need to find longest palindromic substring. Okay, first let's take any substring. Next, BA. So here the first character, which is B, is not equal to its last character, so it cannot be a palindrome. So we can check another substring, BAD. So here B is not equals to the last character, which is B. So this also cannot be a palindrome. So let's take BAB. So here B is equals to its last character. The middle is single, so it's also considered as a palindrome because we can reverse BAB and we still get BAB. So this character comes here, middle characters come in the middle, and last character at the first. Okay, for this string, answer can be BAB and ABA. So ABA is also a palindrome of length 3, so we can return any of them. So question state that if there are multiple palindrome of maximum length, so we can return any of them. So as you can see in the example, ABA is also a valid answer, so we can return any of them and the answer will be accepted. Okay, let's talk about the solution. So first let's discuss how can we check if it's palindrome or not. So let's take a string A, B, C, B. So we can start from first and last character and check if both are equal or not. So here we can see both are not equal. So this is not a palindrome. Let's modify it so it will become palindrome. So we'll start for first and last character. We'll check if they are equal or not. So as you can see they are equal. So we will move our pointer. So it will check B and B. Yes, they are equal. Then there's only single character. So this is our palindrome. So how can we apply this in our current question? So what we can do is we can apply brute force and check every substring if they are palindrome or not. So let's pick any substring, for example BACEC. So here we can see it's not a palindrome. So we will check another string like ACA. So this string we can see that A is equal to A, it's C is equal to C, and this single character. So this is also a palindrome. So this can be our possible answer. So we will check every substring and check if it's palindrome. So we will return longest one of them. So let's talk about time complexity for the solution. We are checking every substring. So finding every substring will take O of n square, and for checking for palindrome, this extra n will be required. So this will take O of n cube complexity, and space will be constant. So this solution will give time limit exceed because it's very slow, and there's a faster way we can solve this question. Okay, let's use optimal approach. So in previous approach, what we were doing, we were checking every substring if it's a palindrome or not. So let's take B A C E with this substring as an example. So let's check if it's palindrome or not. So here we can see B and B are equal, and A and this A is equal. So C and C are matching, and this also. Let's take another string, this one. So A and A are equal. This A, C are equal, and E are equal. So we can see we are checking same substring multiple times. So instead of that, we can efficiently check palindrome. So why this is happening? Because we are moving from start and end and approaching towards the middle. So when we are doing this, we are not checking if this already a palindrome or not. If we know this part of substring is already palindrome, we don't need to check for this whole substring, so our computation will be reduced. So let's see how we can do that. So let's start from first index and check if its left and right are equal. So we can say this is out of bound and this is B, so this is not equal. We will move to next index. Now for this character we can see that its left and right are equal, so we can move its left and right and again check if its left and right are equal. So we can say it's out of bound and this is C, so it's not equal. So we can see that ABA is our current longest palindrome. Now we will move forward to index A. So we can see that B and C are not equal. So we will move to next index to C. Now C left is A and right is E. They are not equal. We again move to next index. Now at E. So here's the important part. So we will check C. Its left is C and right is C. So it's equal. We will expand it. So we will expand our string. Now we'll check its left and right. So we check this A and this A. So they are equal. So again we expand our string. So this is currently a string. Now we again check its left, which is B, and this B. So both are equal. So again we expand our string. So we will continue until and unless we find any character which is different or its end of the string. So we will check this A and this A are equal. So as you can see, this whole complete string is a palindrome. So now our answer will this whole complete string. So we will just compare this length. So its length is greater than ABA, which we found previously. Currently this is our answer. So it's not like we will stop here. We will just continue other indexes as well. You will find this is our maximum. So this will be our answer. Now for coding part, so what we can do, we take two pointer left and right and we'll move towards its left and right and check if they are equal. So if they are equal, we will move them. If they are not, we will just move to the next index and start again. Okay, now if you observe this, we are starting from single index and checking for left and right. So we are always increasing in odd length. So for example, we check single index, so we will check left and right if they are palindrome. So we will have a palindrome of length 3. Then again we will move its left and right, so we will have palindrome of length 5. So this is increasing by 2. So we are increasing, so we are not considering here even length palindrome. For example, if we take A B A B A, so let's try applying that approach. So we'll check A, and its left is out of bound, and B. So now we'll check next index B. Its left is A and its right is B, so it's not a palindrome. Now this B, so we can see this. We won't find any palindrome of length greater than 1, but we know this whole complete is a palindrome. So what we need to do is we will start from 2 element and move its left and right for 2 elements. So why 2? Because we are considering even length. So now if we take two character as at the same time, so we'll increase by 2. But there is an important point, like both of the character should be equal. So we can expand only if both are equal. In this example, we a b, so this is not a palindrome, so we will skip this. No, b b, so both are equal, so this is a palindrome. Now we will expand its left and right. So we will check if its left and right are equal. A and a are equal, so we will expand, and now we'll check its left and right. So we can see this is out of string. No, so this will be our answer. Okay, so the solution boils down to, we will just start from every character and check if it's left and right, and also we will check from every two characters which are equal and check if it's left and right and expand. So this will give odd length palindrome, and this will give even length. So we will just check and return the maximum of them. So if we find maximum even length or maximum odd length, so we will return maximum of them. Okay, let's see the solution. For the solution we need two indexes, start and end, and both will be initially 0. So they denotes starting and ending indexes of the answer substring. So instead of storing string, we will just maintain its index, starting and ending index, and in the end we just return that substring. Okay, now we will iterate every index. Now we will take two indexes, L and R. So both will be initially current point to current index. So this case is for odd length palindromes. So this will for the odd length, and we will do the even length later on. So first we check if L is greater than 0 and R is less than s dot size. So basically both these conditions are for checking if that these both variables are not out of bound, if left and right are valid indexes, and s of L should be equal to s of R. So both of them should be equal. Then we will move the left pointer. If this is the case, we will just move left pointer to left, so we will just decrement, and right pointer to right, for so we will increment it. So this is for moving these pointers if both are equal. Now we will check if R minus L is greater than end minus start. So basically what we are checking is the previous length which is given by end minus start. If it's smaller than the current length, so R minus L will give the current length of the string. For example, we are currently at A, so we will just move left and check if left are equal. So it's currently pointing to B, A, B. Now we will again check if its left are equal, so we just C and this C. So we are increasing left and right. So R minus, so R will point to the last C and L will point to first C. So this will give the length. So we need to find the longest palindrome according to question. So we will check if the length is greater than the previously taken length, so we will update it. So end will point to R and start will point to L. So this will give update our start and end. So this is point to R and L values. Now this for the odd case. Now even case is also similar, so I just copied, but only difference is L it will point to I and R will point to I plus 1. So as explained earlier, so they will be adjacent. For example, AA or BB, so it will move from its left and right. So this code is pretty similar, so there won't be any change. We can create a different function for it, but for now we just do it like this. So this is also moving left and right, so this is similar. Now after this, so let me clean it up a bit. Okay, now this is for even length. After this for loop, we will have our end and start. This will be our answer string, which will be s dot substring. So we need from start to, so length of the string will be end minus start plus 1. So this will be a length. So we need from start to this length, and this will be our answer string. So we need to return this. Let's try and run it. Okay, it's working. uh let's try submitting. So it's submitted successfully. So for the time complexity of the solution, what we are doing, we are using a loop. So this will take O of n, and inside this loop what we are doing, we are moving left and right. So this operation will take O of n, and this also take O of n. So so inside we are looping, we are iterating n elements every single time. So the overall time complexity will be O of n square. And about the space complexity, we are not using an additional space, so space will be O of 1. So this is the solution for this problem. So see you in the another one.